So for the next two problems of this review, I want to go over composite functions. And so we see that we have this notation over here and we have this notation over here. If you haven't seen this small circle, what this really means is that f of g of x, and this over here means g of f of x. And it's quite easy to really just understand this, because what I do is, if I'm given this form over here, I know that, oh, f is the first variable that's given, so I put f here, and then I know that the other one must just be g of x. Similarly here, g is first, therefore we have g as the outer function, and then we have f of x as the inner function, right? So we just have this small open circle here, that it's just the same notation as this, so you could write it as this or this, but this does bring this idea of composite functions. So I have some questions here. So to start off, we have question number 72 here. So we want to find, or we want to determine this and this, right? Whatever, whichever notation you really like, you can use. But for this one, we know we're given that f of x is equal to x squared and g of x is equal to x minus 1. And so we can evaluate the first one, right? So either you write it as this or this, it doesn't matter. I would prefer writing it as f of g of x. So this is equal to, well, you know g of x is x squared. So f of x, or you know g of x, right, is g of x is x minus 1, right? So f of x minus 1 is x minus 1 squared, right? And so if you evaluate this, right, you are just really expanding this, so you get x squared minus 2x plus 1, right? So you should understand that f of g of x is equal to x squared minus 2x plus 1. Now the other notation here, again, I would just write g of f of x. You know f of x is x squared, so we're really saying that g of x squared, which is x squared minus 1. So f of g of x is equal to x squared minus 2x plus 1, and then g of f of x is equal to x squared minus 1, right? So I have a square here, if you can see that, x squared minus 1. So that's just the answer to question number 72. And really what you're doing is, you have your function, right, g of x, you're just putting that into the composite form, right? So if you have g of x is equal to x minus 1, well, that just brings f of x minus 1. And then you have x minus 1, well, f of x is equal to x squared. So if x minus 1 were x, then f of x is x minus 1 squared, because you're squaring that x, right? So that's the basic concept here behind those composite functions. So that's question number 72. And there's another interesting aspect. When you determine f of g of x and g of f of x, if you get both of those composite functions to be equivalent to the value of x, then f of x and g of x are inverses of each other. So I do have a problem for which you will get both of them being x's, right, when you evaluate their composite functions. And so you should understand that those functions are inverses of each other, which you obviously can check, right? Obviously inverse functions are, if you graph them, they reflect over the line y is equal to x, and you can switch their x and y values, right? And so all of those relations. So now we have problem number 73. So this one over here, right, states that f of x is equal to the cube root of x minus 1, and then g of x is equal to x cubed plus 1. So we want to determine f of g of x. G of x is x cubed plus 1. So we're saying f of x cubed plus 1. We know f of x is this. So we're plugging x cubed plus 1 in for this x, right? So doing so, it's the cube root of x cubed plus 1, and we have this minus 1. So the 1's go away, and we're left with x cubed. Well, the cube root of x cubed is just x, right? Those undo each other, so we're just left with x. Now we evaluate g of f of x, right? Again, that's the same thing as this notation over here. And so doing so, that's f of x is this, g of the cube root of x minus 1. And so you can plug this into this function here, and so the cube root of x minus 1 to the power of 3, that's just x minus 1, right? Plus 1 that is also x. So you see this relation here that when you're evaluating both the composite functions, you get x as your value. The fact that they're x indicates, right, that illustrates that these are inverses. These are inverses of each other. So these are inverses of each other. And how you can check, right, you can check that you have done this correctly because you know they're inverses by actually seeing if they're inverses or not. And when I say that they're inverses or not, what I'm saying is, you know, this over here is y is equal to x cubed plus 1, right? So if I rotate or if I switch the y's and x's, when I'm saying I'm switching them, what I mean is this is x is equal to y cubed plus 1. So when we solve this for y, we should get this function over here, right? If we do, then obviously these are inverses, and we have done this correctly because we did get x and x, right? Showing that these functions must be inverses of one another. So we have x is equal to y cubed plus 1, x minus 1 is equal to y cubed, and then cube root both sides, you get y is equal to the cube root of x minus 1. Y is equal to the cube root of x minus 1, and that is equivalent to f of x, right? F of x is equal to the cube root of x minus 1. So that's question number 73, right? So, and obviously if you were to graph these two functions, you would see that these do reflect over the line y is equal to x, right? So now we have question number 74. We have f of x is equal to x cubed, g of x is equal to 1 over x, right? Now we want to determine f of g of x, right? As our first one again, which is this. And so we know g of x is 1 over x. F of 1 over x is 1 over x cubed, right? That is equal to 1 divided by x cubed. So that's what f of g of x is equivalent to, right? 1 divided by x cubed. And then we have g of f of x. Well, you know that f of x is x cubed. G of x cubed is equal to 1 divided by x cubed. And so what's interesting here is that you see that you're getting the same answer, right? But that doesn't matter, right? That doesn't show us that these are inverses. Clearly, if you have y is equal to x cubed, and then you see that x is equal to y cubed, you see if you get the inverse function, right? You should understand that y is equal to the cube root of x. Clearly, this does not equal 1 over x, right? So it should make sense to you that these are obviously not inverses. So the rule is not that your composite functions should be giving the same value in order for them to be inverses. The rule states that after you evaluate both composite functions, you should be getting x, right? X for both, right? It doesn't matter if they're equal or not. So those were the 3 problems that I really wanted to go over to give you an overview of composite functions. So thanks for watching.